What is divergence of a vector field? Divergence of a vector field is the total normal flux per unit volume. Suppose this is a volume V and the total normal flux is equal to E dot ds. Then E dot ds divided by the volume will give you the divergence. Mathematically, we write divergence as div E, that is equal to limit E dot ds divided by V approaches to 0 or tends to 0. And we know E dot ds is the total normal flux. Now we will calculate what is the total normal flux. Suppose this is a volume element, and in this volume element the length this length AB is equal to, suppose, delta x, and BC, this length is equal to delta y, and the length BG, this length is equal to delta z. Then what will be the volume? Volume will be equal to delta x delta y into delta z. Suppose you consider a point P. This is the point P and this is the coordinate system, origin of the coordinate system. This is your x-axis, y-axis, z-axis, and this is the point P having coordinate, suppose x, y, z. Suppose at this point P you have a vector field E. So the coordinate of the vector field will be equal to E, x, y, z. You watch my previous video to know about vector field. And we know vector field can be denoted, since it is a vector, it can be represented by I cap Ex plus j cap Ey plus k cap Ez. Now we will calculate the total flux, that is flux along x direction, the flux along y direction, and the flux along z direction to calculate the total normal flux. Let us first calculate the total flux along x direction. The flux along x direction will be equal to Ex plus delta x divided by 2 into del Ex divided by delta x. I will find out this flux, the flux along x-axis. You have to apply Taylor series. Before watching this video, you should watch my previous video about Taylor series. Taylor series gives you the variation of the function at the vicinity of a point. In this example, you have a point at the you have the point E, that is the vector field at the point E, and what is the electric field? Suppose the electric field at the point E along x-axis. To find out the electric field, you have to apply the Taylor series, and by Taylor series or Taylor's theorem, this is the expansion. If you have a function fx, then the first function will be equal to f x0, the second function will be equal to f dash x0, x minus x0. This is the x0 is a point very close to the point x, so this is the difference, x minus x0. The third point is f double dash x0 divided by factorial 2 x minus x0 whole square, like this. Here the difference of x minus x0, it is a very small quantity which is less than r, and r being a positive constant. And the first function here f x0 we have taken e0, and the derivative of the function f dash x0 is equal to del ex by del x, and the difference of x minus x0, since the length of the length of the container we have taken, that is equal to delta x. So delta x minus x0 is equal to delta x divided by 2. Because if this point is your x0 point and this length is equal to delta x, so at the vicinity point will be equal to x0 divided by 2, and this point will be also x0 divided by 2. So that x minus x0 will be equal to delta x divided by 2. So if you apply Taylor series, Here delta x, you remember delta x is small. That means since the delta x is very small, we have neglected the higher order terms, that is the third order derivative, fourth order derivative. These terms we have neglected. Only we have taken the two order, first order and second order, and that means f x0 and f dash x0 x minus x0. So the first term will be equal to ex, and what will be the second term? F dash x0. F dash x0 will be equal to del ex by del x, and what will be equal to the x minus x0? X minus x0 is equal to delta x by 2. So the second term will be equal to delta x by 2 del ex divided by delta x. So what will be the normal flux on the face BCFG? Normal flux will be equal, since it is a surface integral, we have taken two integrals. So E dot ds surface integral will be equal to that will be equal to Ex plus delta Ex with respect to x into delta x by 2 into delta y delta z. Similarly, the component of the electric field or the vector field parallel to the x-axis in the face ADEH, that is the in the opposite direction, that is why Ex will be equal to negative. So minus Ex plus del Ex divided by del Ex with respect to x into delta x by 2. So what will be the total normal flux on the face ADEH? ADEH means the opposite face of x-axis, that is normal flux will be equal to surface integration E dot ds will be E dot ds, that is equal to minus Ex plus del Ex with respect to x delta x by 2 delta y delta z. So the net flux along x-axis will be equal to, this is along the positive direction, this will be along negative direction. So if you add these two, then you will get the net flux along x-axis. So the net flux along x-axis will be equal to, suppose phi x, that is equal to Ex plus del Ex with respect to x delta x by 2 into delta y delta z plus minus Ex plus delta Ex with respect to x delta x by 2 delta y delta z. So if you add, then Ex and minus Ex, this will cancel. So what will be the net flux along x-axis? That is equal to delta Ex with respect to x delta y delta z, because here you have delta x by 2, here also you have delta x by 2, so delta x delta y delta z. Similarly, you can also find out the net flux along y-axis and also the net flux along z-axis. Then you add the total flux, that is flux along x-axis plus flux along y-axis and flux along z-axis. Then we will get the total flux will be equal to del Ex with respect to x plus del Ey with respect to y plus del Ez with respect to z into delta x delta y delta z. And what will be this total flux? That will be E dot ds. So integration E dot ds will be equal to this quantity. Then if you divide the total flux with the volume, then that will give you the divergence. So divergence of E or the vector field will be equal to total flux, that is integration E dot ds divided by V. This is your dot. So E dot ds divided by V, then this will be equal to this quantity divided by the volume is equal to nothing but delta x delta y delta z. So this quantity delta x delta y delta z will cancel. So divergence of E will be only del Ex with respect to x plus del Ey with respect to y plus del Ez with respect to z. In the previous video, I have discussed about the del operator. Del operator is equal to I cap del by del x plus j cap del by del y plus k cap del by del z, and the vector operator, that is equal to I cap ex plus j cap ey plus k cap ez. So what will be del del E will be equal to, when you take the dot product of I cap, this is the dot product. So it will be equal to 1, j cap 1, k cap 1. So this will be equal to del Ex with respect to x plus del Ey with respect to y plus del Ez with respect to z. So if you compare equation 1 and 2, then divergence of E will be equal to del dot E. So you have to remember this equation, what is del dot E and what is divergence of E. Both are same. Divergence of E is equal to del dot E, and that is equal to this this value. You have to remember it, and remember the dot product of two quantity, physical quantity, is a scalar quantity, and here the divergence of a vector is a scalar quantity. You see, divergence of a vector will be a scalar quantity. Then what are the physical significance of divergence of a vector field? If divergence of a vector field is positive, then flow of vector is outward and fluid is expanding, and the density will decrease in density, and point we called a source point. If the divergence of a vector field is negative, then flow of vector is inward and fluid is contracting, and there is increase in density, and the point is called a sink point. And if the divergence is equal to 0, then there is no flow vector and the fluid is neither expanding nor contracting, and the fluid is called as incompressible. So when you talk incompressible, means the divergence is equal to 0. Then what is a solenoid field? Any vector field whose divergence vanishes or when divergence is equal to 0 for any surface, it is called a solenoidal field.